ADISA. Thank you and welcome to ITAD in 15, the first one of 2024. I'm just laughing because myself and Garry were chatting. I'll introduce Garry, but we can't work out how to correct his surname on Hopin. So one of us has spelt it wrong and we're blaming each other. But I'm joined with Garry from Secure IT Services. Good afternoon, Garry.
Good afternoon. Good afternoon, Steve. Good afternoon, everybody.
Today's topic on ITAD in 15 is about media destruction and talking about the subtle nuances that exist within that process. And Garry has been reacquainted to me. We've known each other for about 15 years now. And I had the fortune to do some work for the first time with Garry at the back end of last year to verify shred output for some new shredders that he had. And it was during those discussions that I actually learned a little bit more about what it takes to build some of this machinery, which is why we're speaking today. So Garry, let's kick things off a little bit. Every shredder's the same, isn't it?
Yeah, we would hope so, but I think a lot of people have that opinion that a shredder's a shredder, and I don't think they appreciate the different type of materials that we need to shred. So we do, as I say, we're now onto SSDs, but generally a hard drive. I was having a conversation with someone last week who was ringing me up for my advice, saying I bought this lovely big shredder, and I can only do X amount of hard drives per hour. So we started discussing, and they literally didn't realise the difference between a PC hard drive, an enterprise drive, a 2.5 inch SSD. They just naturally assumed this thing was going to do 100 drives an hour. And after sort of going through 6 mil and so on and so forth, how long it would take, how many kilos I think they should expect per hour, and the different weights on and densities of the drives that we're trying to shred, they were sort of, expectations were higher.
So let's talk about the mechanics for those who may not be familiar. Go into your engineering background. Let's talk about what are the moving parts in a shredder.
So all the shredding what's been done up till now has really been based around HDDs. So most of it is very dense. It's the bearing, which is the hardest bit of a hard drive. And as we've gone through the years, the drives have got bigger, denser, and harder to chew through. So what we're using in our shredders nowadays, or have done up till now, is very high torque and low speed, just to try to cut through the initial dense parts of a hard drive. So then obviously once we've cut through the denser parts and taken it down into smaller pieces, we can then start chopping away and trying to bring that down into particle sizes. But I mean, for instance, we did a job last year, which was a bit of an eye-opener, where we was going through, I think it was about 6 hard drives in an hour, and each hard drive, once you've obviously cut into it, every single platter had its own shelf inside the hard drive, so it's almost like a solid piece of metal. So your machine, where you're expecting it to do 6 mil particulates at 10, 12 kilos an hour, you're doing 4 kilos an hour just by the sheer density of the enterprise drives.
So again, media destruction, there's different types of destructions. We'll focus just on shredding for now, because that's clearly where we got reacquainted. So we're talking about magnetic hard drives is more of the traditional, it's where we've come from. Spindles were the problem for the physical process of actually shredding them. So we looked at a mechanical process of, as you said, high torque, low volume to actually deal with the spindle, with mostly interest from security for the platter, of course. What you're seeing is customer expectation is that they want speed. So they want you on site to shred, and they want you off site as quickly as possible. So you're talking about throughput. Being realistic with a server drive, what can you shred? Not necessarily with your shredders as they are today, because I know you've just re-engineered them. What would a typical shredder be able to process in your view?
It really comes down to the drive you're using. Every drive is different. As I say, it comes down to density, the makeup of each drive. Obviously, some drives are built better than others. And the size of it. So when we're doing shredders, we sort of try to estimate time on site by how many kilos per hour we can do at a certain particle size. And that's sort of our finger in the air guess, because until we get to site, we do not know what the makeup of those drives are going to be. As I say, and that could be anything from, as we've experienced, anything from 5 kilos an hour to 20 kilos an hour at 6 mil, for instance.
And we're going to talk. There's some bits which we know we're going to cover. So just going to lead the conversation through for those listening, if I may. So we're talking about, you mentioned 6 mil, and we're talking about particle size. So we have within the shredders, you have the teeth, which will cut rather than chew, ideally. The device that you're presenting, and then the particles will drop into a sieve and to a screen. The aperture in that screen is often what people use in their marketing claims to say it's a 6 mil shred. In your eyes, does a 6 mil screen equal a 6 mil particle size?
As we discovered, 6 mil aperture, if we can all claim we have a 6 mil shred sieve. In reality, if the individual's shredding device or machine is not maintained properly, what we've discovered is the older the blades, the less cutting that blade's going to do. And because it's a high torque, it's almost forcing something which is 6 mil wide to be forced into a hole which could be 10 mil long. And it's rather than cutting and a particle falling through the sieve, it's actually forcing it through the holes of the sieve. So when you actually get the output is not a 6 mil particulate. It might have a 6 mil dimension somewhere, but the actual output is considerably higher.
And we'll lead on to talking about the testing that we did with the Vizion. So we've got a new certification called Vizion, which is a blend of using high imagery through some software to actually verify particle size. And we used Garry as the guinea pig. So thank you very much for allowing us to come and play with your shredders. Now, we went through, and those of people who know Garry listening will know that he didn't give you an easy ride on this. And you remember the diagrams that we got through. And we said, hang on, we were trying to work out how the software could look at it in 2 dimensions, in other words, the 2 longest sides. How we get a realistic size on this. And we both got to the same point where you go, well, of course, it's the cylinder effect. And it makes perfect sense that if you're talking about an aperture of a hole, that there is a 3rd dimension, which is the depth. And what I've always struggled with, and your experience of doing this day in, day out for 10 plus years will probably carry more weight than mine, was how you could avoid having a longer particle size just due to the physical mechanics of how a shredder worked. And I always kind of didn't understand that. I mean, in your eyes, when people get approvals in this area, not just talking about Vizion, but get approvals in this area, is it aperture size that they're verifying, or is it particle size, do you think?
I think, including myself, up until we worked together on this, I would always advertise and sell our service based on the aperture size of the sieve, with it naivety. So if we're talking about, do we do a 6 mil sieve? Do we do a 6 mil shred? Yes, we use a 6 mil sieve, and what comes out has a 6 mil dimension to it. And you would hope the majority of them will come out with a small variation. But what we did find out is, because it is so slow, more particles which were reasonably long, I mean, we might say 10 mil, but were coming through because they were being forced. And we had a machine which only had 50 hours of cutting on, so our blades were quite fresh. So you can imagine a machine that's got 200-300 hours of cutting or of shredding, how blunt those surfaces are where they meet, where they cut. And it doesn't matter if you're not doing a particle size, you're just putting the strip shred through. That doesn't matter. But when we start getting to particle sizes, you want it cutting and you want it dropping through rather than forcing it through the hole.
I think, just hopping back a little bit, I'm aware of time when we're talking about shredding specifically. Let's talk SSD for shredding, which is a different beast entirely, in my opinion, different technology. If you're looking at data recovery from a shredded magnetic hard drive, if the interface has been destroyed, which most physical destruction processes will destroy the interface, then you're talking at a platter level recovery, which is a reasonably high-end attack. SSD is slightly different. Now, the different architecture of that has caused some issues in the shredding sector. And I know particularly in the US there's some issues because they're still using larger shred. Have you seen more sophistication from customers asking for more precise shredding on solid state storage devices?
The conversations there, I think what it's come down to up till now is people haven't got the machine to do it. I've seen manufacturers out there claiming to have a 2 mil SSD shredding machine, and you read through the literature and their sieve is 3 mil. So it's like, how do you claim a 2 mil SSD shred when you've got a female sieve. And I think there's a lot of people out there claiming that they can do stuff which they can't do. Hence why you and I had a conversation to verify what I say is what we can do.
I think if you look at what are we trying to achieve, we can drive, as I think the services have done in the UK. They've driven the sizes down smaller and smaller and smaller as technology evolves and data gets denser and denser. That's been the theoretical reason and justification for doing this, as opposed to how can we recover data. And I think that's the approach ADISA has always taken. With SSD, I think with magnetic hard drives, our gut feel is that a larger particle size is still sufficient, because it's still the same type of data recovery, which is a high-end attack. Yes, there's greater density of data, and so the data that you would recover if you were motivated would be greater, but you've got to access this stuff and you've still got to mount that attack. SSD is different because we're seeing micro flash chips now, which are even smaller. And so in our eyes, we've been cowards with the ADISA ITAD standard, because it's technically correct. What I'm about to say is that all we say is that every NAND cell must be impacted. We haven't specified a size, because in actual fact, as technology is evolving, that size is going to change. My gut feel is, we used to be 6 mil on SSD, but my gut feel is that if you're aiming for SSD, it should probably be closer to 2. That being said, there are other controls, aggregation, anonymization, and physical security that could come into play. So that's why at ADISA we're still saying just impact every NAND cell. Can we talk differently? I know it's not your subject matter necessarily, but let's talk other physical forms of destruction. There's a new standard in the States, IEEE 2883. It's the best sanitization standard that we've seen for a long time. It's, I guess, the older or the younger brother to NIST 888, and it's got an awful lot of really good stuff in there about logical sanitization. A very interesting change has been its removal of shredding as a viable form of physical destruction of media. So they've removed it. It's no longer, they view it as obsolete, which we at ADISA disagree with. And they recommend incineration amongst other things like pulverization and things like that. If we talk incineration, Garry, what's your experience of having to deliver a service where customers say it must be incinerated? Have you got experience of that? And are there any vulnerabilities associated with it?
It's an old conversation with the incineration. Some people have facility to do it themselves, but the way I look at it is data tapes, for instance, was one of the key facts of having it incinerated, because everyone was saying that they could do these particulate size with data tapes and so on and so forth, and they really can't. It goes through the shredder, it comes out in big spools and so on and so forth. And they shred it, and the reason they shred it is because they've got no control of custody at the incineration site. And because there's no control there, then there's still data on those big streams of fish, microfiche, or whatever you call it, the actual tape itself. So incinerators are great if you've got your personal own incinerator and you can have control of custody. But realistically, the incineration plants around the country are there's too much capacity, or there's no capacity left, and you can't get in. And if you're lucky to get it in, you drop it off and you just leave it. So in respects to data control custody, it's a terrible idea.
And I think just picking up on that, tape is really difficult. Data is written in a linear fashion. So as you say, if you chew tape and you pull it out, you can apply a reasonably straightforward read of that tape to recover the data. So that is a challenge, and incineration has always been the preferred option after a shred for treatment for transportation. But the point you make is very valid. Chain of custody. Now I've had the pleasure of driving the jaws of death as it lifted stuff and dropped it into an incinerator at a site in Birmingham, which was great fun. And it is a very agricultural process. It's big. There's an awful lot of cavernous areas here. So if you're looking at real asset management, it was always a big challenge for us to achieve. And that's why we were there trying to look at how we could promote this. And I think the point you make is really good. If everybody's that worried about data recovery that they're saying you must incinerate, there seems to be a huge difference when you say, well, I don't need to track it. And this is where we think incineration isn't necessarily what people think it is, which is, a finite process, because in actual fact, whilst the fires will burn, you've got to get it there, and that increases the level of risk with transportation and handling, and that's a concern for us. We also are aware that there's no incinerator in the UK who's prepared to sign a data processing agreement today, as far as I'm aware, which means that you can't use that as the end point of sanitization under GDPR, because you're not dealing with the data processor. So there's an awful lot of subtlety about incineration, that the belief that the fires will solve everything, the little subtlety about the service delivery that causes problems. Let's just talk degaussing as well. I'm just aware that we've gone over a bit, but we're going to carry on. Degaussing, what's your view on that, Garry?
In the past, we've had clients claim that they've degaussed equipment, and big clients, and we brought the equipment back, done data forensics on it, and got all their data back. So I'm not an advocate for it for hard drives. Data tapes, I think potentially yes, if it's a decent degaussing machine, but I would still degauss and then shred. So I think it has a purpose for data tapes. I personally don't. I'm not an advocate for anything else.
I think it doesn't work on solid state or flash media, so it's straight away a huge volume of storage is taken out of its scope, if you like. Like you, I think it's got its place. Tape is an obvious one for me, but the big issue I have, because I'm really old-fashioned, is the lack of physical change. And so a device, when you degauss, it still looks the same. And yes, you'll have process controls and you can put labels on, things like that, but there's still an element of doubt. And when you're talking about some of the older degaussers, which had hotspots with different variables and output, where you had casings on drives, particularly in the data center, removing the caddies, people get lazy and leave them in. Effectively, it shields it. There's a little bit of handling control there that's needed, which is why we've always been, certainly me personally, have always been a bit reticent to promote degaussing. I think it has its place without a shadow of a doubt. And I think when it's done correctly, it works. But there are some tricks, I think, that need to be understood in order to make it really, really effective. We're just going to finish because we've run out of time a little bit. I do want to talk about the new devices, the new shredders that you've designed yourself and had manufactured yourself and are now brought into production, the ones that we tested. You submitted 2 for testing. What sizes were they for? What target media were they for?
So we had a standard HDD shredder, which we done at 6 mil. And we also introduced our new 2 mil SSD shredding machine, or electronic component shredding machine, which can also do data tapes to particulates. Just a little plug there.
I think we're not, so ADISA's independent. But the interesting bit for me, as a certification body, we sit on the sidelines and we don't actually do what you guys do. So you can turn around and go, you need to do this, you need to do that. And in reality, sometimes it's perhaps over the top, and we know that, but you have to aspire to drive improvement. The one thing I will say, we think 6 mil, if it impacts every NAND cell on SSD, works, but it's got to impact every NAND cell. It means the shredder's got to be fit for purpose. You've got to have the right controls in place. The one bit that I was really surprised was the output. So our auditor went on site with control drives and shredded them, and it was a single pass. And the output, when they came back, I challenged the auditor and said, how many times did he put that through? And it was once. Now, is that what you were striving for with your 2 mil? Was a single pass through to get to that size that you wanted? Yeah.
So there's people out there, again, because of the 6 mil particular, and you want that when you've got the blades turning, you want to constantly turning and not backing off, because you obviously reduce the amount of throughput you can get. So there were people that were doing a double shred, so they would shred a hard drive with a bigger particulate and then put it into a 6 mil. And I didn't want to have to take 2 shredders on site or switch the sieve over halfway through and then redo it. So the whole idea of this new machine was I wanted something which we put in and the output was exactly where we wanted it or better. And I think we definitely achieved that.
And I think just to close, because time is only meant to be 15 minutes, we said we'd talk. I didn't realize that's a process, I'll be honest, where you'll take two shredders to site, where you'll achieve an initial shredder, maybe you'll take it down to a small size. I didn't know that was a thing. Is that commonplace to achieve the smaller output customers require?
When we're talking about time on site, so we can get 6 mil, it's not a problem. Our hard drive shredder machines will do from a hard drive straight to 6 mil. That's not a problem. What you're trying to do is speed up the process. So if you've got a lot of drives, you would potentially could pre-shred to a larger particle, and then just have the 6 mil particle machine going constantly without it backing off. So it's just constantly chopping and chopping and chopping until we get that 6 mil particulate. That's the only reason I would use 2 different machines. But it'll be because there's a large number of drives and we just want to get that 6 mil cutting without it stopping so it backs off. Because that's a lot of time it takes off.
I think just to close, I'll try and summarize it, Gary. If I get any of this wrong, jump in. You won't be shy anyway. I think what we tried to get across today, and we were talking about, was different media requires different shredding solutions, and one size doesn't fit all. Talking of size, that there is a little bit of a misnomer about what size we're talking about, whether it's the screen size or the particle size, and does it matter? Well, the answer to does it matter is up to the client's own threat profile and own risk appetite, because data recovery techniques can be applied to complete NAND cells. We can do that here with chip readers. It can be required to apply to broken NAND cells, which is decapsulation, and you can do it to shredded platters. You have to look at likelihood there, and that's where the ITAD security controls come in place to stop access to this and make the likelihood of that attack really, really limited. The other bit which you mentioned, I've underlined, is maintenance, and there's nothing in the ADISA standard about maintenance of shredding equipment, but that strikes me as being critical. You talked about the number of hours your blades had to do its performance, and that's all about the output. And I think that's a really important thing to draw out from today as well. And also that there are other options for media sanitization, of course, physical destruction, I should say. Incineration is one that we're probably both a little bit reticent about. Degaussing, I think, as we both said, has its place, but again, there's some limitations on it. And it really is, if you're talking physical destruction, for confidence sake, it would be a physical deformation of the drive to ensure that you can see that the data has been impacted in the way that you want it to, as opposed to something where you're trusting a system or systemic control.
It's definitely that visual part. So even if you wiped a hard drive on site and it failed to wipe, you would still want to deform it before you took it away from site. So even if you used a crusher or something, just as you say, the visualization of that drive to say that it can't just be spun up.
Yeah, and I think that's important because there's processing that you can do. So degaussing, for example, and deforming can be used as before a final process to restrict the likelihood of somebody grabbing a drive and accessing it in a simple way. We've gone over time. We knew we would. We're up to 20 minutes. But Garry Costen, and I managed to find out how to correct your name as we were speaking as well. Apologies, it was my fault. Thank you, Garry. It's lovely to chat to you again. If you can stay on, we'll just wipe up at the end. Thank you, everybody, much. You will receive a link to this. We're going to do some editing and it'll go live. All the other ITAD M15s are available on the ADISA website. If you go on it, there's a link to the ITAD M15. There's 4 up there. Next month, I believe, because it's January, next month's going to be Orla, who's a data protection barrister. We're going to be talking about GDPR and GDPR certification schemes. Thanks, guys. Enjoy the rest of your January. Take care.
Thanks, Steve.